all, you will write your matrix in the form of determinant. Okay, first of all, you will write your matrix in the form of determinant, and determinant is written with straight lines. Okay, with straight lines. 2 minus 2 5 1 3 3 1 3 1 1 2 1 4 3 5 6. So these straight lines represent that we are working with determinants. Okay, these straight lines. So now I am deleting this. So when we are dealing with the determinant, row operations will be applied with the same manners the way we did in the previous sections. The only difference is that when we are interchanging the rows, so minus sign will be placed outside each time you interchange the rows. Okay. So for example, in row reduction method or row operations, what is the objective is to get top leading element 1. The top leading element must be 1. So in your opinion, what should I do to make the leading element 1?
Change the row 1 to row 3.
So I have to interchange row 1 with row 3 because row 3 is having 1. So I will interchange row 1 with row 3. So I am placing row 3 in top and row 2 will remain row 2, and 2 minus 2 5 1, and fourth row will remain the same. Okay, I have just interchanged. Now I am interchanging rows in determinant. So in determinant we'll keep minus sign outside each time we interchange the rows. Whenever you change the row, interchange rows, you will put minus sign outside. Okay, so that is a compensation is needed in the form of determinant when we are dealing with determinants. Okay, now we got the leading element 1 and you already familiar with the row operations. So my objective is to convert 3, 2 and 4 to 0. So you already aware of it. What I need to do to have the leading element, the leading row will be the same one, and row 2, row 3, row 4 gonna be changed. Why? The opposite sign of minus 3 is minus 3. So minus 3 plus 3 answer is 0. Minus 3 multiplied by 1 and plus 3 answer is again 0. Minus 6 and 1 minus 5. Minus 3 and plus 3 answer is again 0. Okay, again.
So the other one is 1 1 2 1.
Yes.
See the row. It's different.
Oh, sorry. 1 1 2 1. Yeah. So minus 3 plus 3 0. Yeah. 6. Yeah. Okay. Fine. Clear? Now for the third row, minus 2 is the reverse sign of 2. Minus 2. So minus 2 multiplied by 1 is minus 2 plus 2 answer is 0. Minus 2 minus 4, minus 2 and minus 2 minus 4, and minus 4 and plus 5 1. Minus 2 and 1 minus 1. So the opposite sign of 4 is minus 4. So minus 4. So you will be considering here, let me with different color. Minus 4 will be multiplied to each number and then will be added to the row 4. So minus 4 multiplied by 4, answer is minus 4, plus 4, answer is 0. Very good. And minus 4 multiplied by 1, minus 4, and plus 3, minus 1. Minus 4 multiplied by 2, minus 8, plus 5, minus 3. Minus 4 multiplied by 4, minus 4 and 6, 2. Okay, so that's what we obtained here. After that, so what is to be done? So you have to pick a column, a row which is having most zeros. Which column or which row is having most zeros? Which column or row? So column 1. Column 1 is having most zeros. So in column 1, what is the leading element? A11. Okay, and correspondingly you have to pick M11. Okay, so and minus will remain outside, this minus. So what you are doing, this minus 1 will remain outside. So you are picking A11 along with M11. So minus again is there. What is A11? What is A11? 1. The leading element. The position is A11. And M11 is the minor. And how do we calculate the minor? Minor is exclude row 1 and column 1. So what is remaining? 0, minus 5, 0, minus 4, 1, minus 1, minus 1, minus 3, 2. That is what is remaining as a minor M11. Okay, clear? Now again you have to pick whatever is here. Minus 1 multiplied by 1, answer is again minus 1. Minus 1 multiplied by 1, answer is minus 1 again. And then again we have to pick a row or column which is having most zeros. So which row or which column is having 0? First row. In the first row, which element is a non-zero element? Minus 5. What is the location?
1, 2.
A12. Very good. A12 is the location of minus 5. And correspondingly you have to take M12. Okay? Yes.
Can we have the remote please?
Again. So now we need to write one thing here. Whenever your M, the location of your M is odd, you should write with negative sign. Okay, whenever the location of your M is odd, you have to write with minus sign. So it means that I should write it as minus M12. Okay, always. And then now I just need to write minus 1 multiplied by minus 5. Why minus 5? Because A12 is minus 5. Okay, and M12 should be exclude row 1 and column 2, because it's a minor. You have to exclude row 1 and column 2, minus 4, minus 1, minus 1 and 2. Okay, so minus 1 multiplied by minus 5 and minus 5 multiplied by minus 1, so all together we are getting minus 5. Okay, and then minus 4 multiplied by 2, minus 8, minus 1 multiplied by minus 1, 1 with minus sign or plus sign? Minus sign, because minus minus plus, so when we are going up we have to have a opposite sign. So all together we are getting minus 5 and minus 9. So answer is 45. That is the determinant with row reduction method. Okay, that is the determinant by row reduction method. I'm turning the recording again on. So leading element is 1. So what you need to do is to make the all non-zero element below 1 should be zeros. So the opposite sign of 2 is minus 2. Minus 2 plus 2, answer is 0. Minus 2 multiplied by 0, answer is 0. 7 will remain 7. 0 will remain 0. Minus 6 plus 6, answer is 0. 0, 6, 3, 0 will remain the same. Minus 2 plus 2, answer is 0. Minus 3 will remain 3, 1 will remain 1, and minus 6 and plus 5 is minus 1. Okay, again we could pick the leading element. So it is not only that you could just pick the leading element 1. Okay, so you can pick any of the element from any of the column, any of the row. Okay, but preferably we'll try to pick the row or the column which is having most zeros, because the objective is that for all the rest of the entries there is no need to write the minors. Okay, we will write the minor for the only non-zero number. So here we could identify that A11 and corresponding 1 1, that is the best one. That column is the best one. Okay, and we know that A11 is 1 and corresponding M11 is 7 0 0 6 3 0 3 1 minus 1. Okay, and then again the leading element you can pick A11 M11. So your A11 is 7 and M11 is, exclude row 1 column 1, 3 0 1 minus 1. Okay, so 1 multiplied by 7 is 7, and 3 multiplied by minus 1 is minus 3, and 1 multiplied by 0 is 0. So we are getting minus 21. Okay, that is the answer of the determinant. It's very easy. So the number whatever you are picking, you have to write a corresponding minor. You could see that M11 is 1 plus 1 is which location? Odd location or even? Even location. So I did not write with minus because it is already even location. So when it is odd location, then you should write with a minus sign. That is the only thing. Okay, so you will write your matrix okay. So in determinant you could extract any common element from any row or any column. For example, minus is sign with A with minus B and minus C. So you could extract each of minus sign outside because it is in row 1. Okay, so minus 1 could be written outside. Okay, and then this 2 is also part of the second row, so this 2 could also be extracted outside, and 3 is also part of row 3, so 3 could also be extracted outside. And what is remaining? The remaining is A, B, C, D, E, F, G, H, I. Because minus 1 is existed in row 1, so we can take all minus outside, and 2 is existed in row 2, we could take all 2 outside, and 3 existed in row 3, we could take 3 all outside. So ultimately this is given as 6, minus 6. So we could write minus 1, 2 multiplied by 3 into minus 6. So altogether minus plus 6 multiplied by 3 is 18, multiplied by 2 is 36. So 36 is the answer. Okay. So in determinant, let me tell you the property of this is one of the property of the determinant. For example, in matrix, let me tell you the difference between the matrix and the determinant. So for example, if you have 2, 4, 6, 8 in the form of matrix, okay, and you wanted to take out 2. So what you will do, you want to take out 2, so you will write here 1, 2, 3, 4. So all the elements are linked with 2 in matrix. Okay, when we are talking about the determinant, so for example, we have again 2, 4, 6, 8. So let me write in the form of determinant. So in this case, if you want to take out 2, so this could be extracted from a row and or column. Okay, for example, you wanted to take out 2 from outside, so this will be written as 1 and 2, and the rest 6 and 8 will be written as it is. The next row will not be impacted, which is impacted in the form of matrix, but it is not impacted in the form of determinant. So if you wanted to take 2 from the second row, so you can take by 2 multiplied by 2, so 1, 2, 1, 2, 3 and 4 by this way. Okay, so this 2 have been taken from the first row, and the second 2 have been taken from the second row. So that's how the behavior little bit changes in the determinant. Okay, and for example, you could not only take the common from the rows, you could take out the common from the column as well. For example, you have been given this matrix A is equal to 2, 4, 6, 8 in the form of determinant, and my objective is to take common from the column. This is column 1, this is column 2. Okay, and I wanted to take 2 common from the column 1, so I could write 1, 3, 4, 8 by taking 2 common from column 1. Okay, and for example, ultimately I have to take 2 common from the second column, So 1 3 will remain as it is, 2 and 4 will be there. Okay, so that's how you can manipulate with the determinants. Okay, in matrix all the entries are linking. For example, if you are multiplying with any number, so you have to multiply with all the entries in matrix. But when you are multiplying a number with in determinant, so it will be multiplied to a row or any column. Okay, you cannot multiply to all the entries in the determinant. So that is a little bit a difference. Okay, yeah. The first step is to try to get the formulation according to what the given is: a1 b1 c1, a2 b2 c2, a3 b3 c3 equal to 7. So we need to change this evaluation according to what is given to us. So the first step you will going to do here, you will subtract the column 1 with column 3. Okay, so you have to perform the subtraction. Okay, c, that is c1 minus c3 column, minus c1 and c3. This is c representing columns, not this c1 and c2. Okay, columns, column c3 and c1 and c3. You will do this, and it should be the c1 will remain as it is, b1 a1 c1, b2 will remain as it is, b2 a2 c2. So when we subtract with this one, so b minus b1 and plus b1 will be cancelled. So what is remaining? Minus 3b3. So minus a1 and plus a1 will be cancelled. What is remaining is a3. So minus c1 and plus c1 will be cancelled, and minus 3c3. We have this one, we got this one. Okay, so out of column 3, minus 3 can be taken out. So we are remaining with b1 a1 c1, b2 a2 c2, b3 a3 and c3. Okay, so we just putting equal signs, and minus 3 into the transpose of the determinant. Okay, is the same as the a. For example, the transpose determinant and a determinant will give you the same answer. Okay, therefore we can take the transpose of this. So the transpose will be b1 b2 b3 a1 a2 a3 c1 c2 c3. That is the determinant. Okay, now you need to see that according to your formulation, the column c1 should be interchange with column c1 change column change to column 2. Okay, so what you have to do, you have to have a minus sign outside, because you are interchanging the columns. So a1 a2 a3 will remain as it is, b1 b2 b3 will remain as it is, c1 c2 c3. Okay, we just interchange. So now this is the clear representation which is indicating it as 7. Okay, this one is equal to 7, so it means that minus 1 minus 3 multiplied by minus 1 plus 3 multiplied by 7, answer is 21. Okay, there.